All right. We're going to multiply and divide some rational expressions. Now, we've done multiplication and division with fractions before, right? Multiplying is nice because you just multiply across the numerator and across the denominator. Dividing, you do the old keep, change, flip. Huh? Remember that? So if you look at A, we just multiply across the top. 3 times 4 is 12. In the denominator, x times x squared would be x to the third. So we'll have 12 over x to the third. That's almost too easy. Now, eventually we're going to get to the point where we're going to be simplifying stuff. I would recommend simplify early if you can. So let's see. Does anything simplify on B? No, because there are no groups that are exactly the same. There's no common factor on the outside. So you could... Some teachers might have you actually multiply x times x minus 3 and make it x squared minus 3x. I'm not going to have you do that. I'm going to have you write them just like as products next to each other. So like x times x minus 3. Same thing with the denominator. You might have a future teacher that wants you to FOIL that out. Multiply first, outer, inner, last. I don't want you to do that. I want you to leave the denominator as x plus 4 times x minus 2. Which I hear your cries, but Mr. Plant, we didn't even do anything on that problem then. Yeah, that's all right. I know where we're going with this. Trust me. We're going to want it like that. All right, on A, over here. Again, it's very similar to the other A. We're just going to multiply across the top. 6 times negative 2 is negative 12. Denominator, a to the second times a to the third. Remember, when you multiply, you add the exponents. So that would be a to the fifth. On B, any common factors that could cancel out? No. So we'll just go ahead and mash them together. Numerator, x minus 5 times x minus 7. The denominator is x plus 3 times x. I'm going to put the x out in front just because that's like usually how you would see it. If you had it at the back, that's fine. It's just not typical. All right, cool. Of course, we got to dial it up. This is too easy at this point. Ooh. You always have to factor when you're doing these type of problems. Factoring, it never goes away in math class. So we're going to multiply 2x plus 1 over 3 and 6 over 4x squared minus 1. Now, 2x plus 1, there's no common factor. So I'll just go ahead and write it in parentheses because I bet it's going to cancel out somewhere else. Over 3. We're multiplying it by 6x over this 4x squared minus 1. Now, I do notice that 4x squared minus 1 is a difference of squares. Those are both perfect squares, and there's a minus in the middle. So when we factor that, remember you square root each part, you put one with a plus and one with a minus. So the square root of 4x squared is 2x. The square root of 1 is 1. So that's how 4x squared minus 1 would factor. Now, do you see any common factors? It just needs to be from any numerator and any denominator. I see they both have a 2x plus 1, so we can get rid of that. There's something else we can do. The 3 with the 6. Those are both monomials. They're both single terms. So 3 goes into both of those. 3 goes into 3 one time. 3 goes into 6 two times. So all we have left in the numerator is 2x. The denominator, we have the 1, but we don't have to write that. All we have left over here is the 2x minus 1. You could write it in parentheses, or you don't need to. Now, again, we've talked about this before. Someone's going to see the 2x over 2x and be like, oh, we can simplify 2x over 2x. If it was just 2x and 2x, sure. But this 2x in the denominator is grouped with the 1 with subtraction. So it has to be factored out, or it needs to be the full group with a full group. You can't just take part of a group and simplify it with a monomial. So that's as far as we can go on that one. All right, multiply x minus 2 over 8x, negative 8x plus 6 or minus 16. All right, we got some factoring to do. Now the first fraction, there are no factors. X minus 2, nothing to do there. 8x, nothing to do. But I see our lead coefficient is negative with the negative 8x. And I know that 8 goes into 8x and 16. So I'm going to factor out negative 8. Negative 8 times x is negative 8x, and negative 8 times positive 2 would give us that negative 16. The denominator, x squared minus 4, again, that's a difference of squares like we had on the first one. So we square root them both, put one with a plus, one with a minus. X plus 2 times x minus 2. Now, do you see anything that will cancel out? Well, I see they both have an x minus 2, so we can cancel those out. Heck, they even got an x plus 2. OMG. All I have left is negative 8 over 8x. If only there was something else we can simplify. The 8s. 8 goes into 8 one time, 8 goes into 8 one time. So all we have left in the numerator, the only thing that wasn't canceled out, is negative 1. All we have in the denominator is 1x, which we could just write as x. So negative 1 over x. What? That was fun. That was real fun. Almost as fun as this. Whoo! We're multiplying this. Now, you're like, that second one's not even a fraction. Everything's a fraction, man. It would just have a denominator of 1. All right, so let's factor 3s plus 2. They don't have a common factor, so we'll just leave it. 3s plus 2. The denominator, 2s plus 4, those have a 2 in common. So we'll factor out the 2. 2 times s is 2s. 2 times 2 is 4. Boom. We're all factored up, baby. Denominator's 1. Factors of 6 that add up to 5 would be 2 and 3. S plus 2. S plus 3. We've factored everything we could. Is there anything we can now get rid of? Ooh, they both have an s plus 2. That's it. So, in the numerator, we have the 3s plus 2 times the s plus 3. No need to multiply them. In the denominator, we have 2 times 1, which is 2. That's our final answer, and we're having fun. There it is. All right. I think you should try 2 of these 3. Any 2 you want. I'm going to go over them pretty quickly up here. So go ahead and pause, try 2 out, and then check back in and see how you did. All right. 3 over c. C cubed minus c has a c in common, which leaves you with c squared minus 1 over 1. All right. The c's will cancel out. Nothing else. So it's just 3 times c squared minus 1. That would be our final answer. Now I will say that can still be factored into c plus 1 times c minus 1. Both of those answers would be fine. Or if you wanted to multiply in the 3, make it 3c squared minus 3. All 3 of these answers are good to go. 2v over v plus 3 ends in minus. I know that has to be a positive times a negative. Factors of 15 that are 2-part are 3 and 5. So to make it add up to negative 2, have to be minus the 5 plus the 3. Now we can get rid of the v plus 3's. Our denominator is just 1, so it'll go away. So numerator, we have 2v times v minus 5. That would be the final answer I would prefer, but if you'd like, you could certainly distribute that and make it 2v squared minus 10v as well. All right, m minus 1 over 1. 4m plus 8, they have a 4 in common, m plus 2. M squared minus 1 is a difference of squares, m plus 1 times m minus 1. And now we can cancel out the m minus 1 for the m minus 1, and that's it. So we have 4 times m plus 2 in the numerator. We have 1 times m plus 1 in the denominator. So that would be it. And again, if you want to distribute the 4, you can. 4m plus 8 over m plus 1. I wouldn't even recommend that, though, based on where we're going from here. All right. Division, it's the same thing. We're going to change it to multiplication. We're going to do the keep, change to multiplication, and flip the second fraction. So the first fraction, let's factor everything. Factors of 10 that add up to 7 would be 5 and 2. So that'd be a plus 5 times a plus 2. Our denominator, a minus 6, we can't do anything with that. We're dividing it by this. We're going to change it to multiplication and use the reciprocal, meaning we turn the fraction upside down. So this a plus 5 now goes to the denominator, and the a squared minus 36 is now in the numerator. Again, that's a difference of squares, so that would factor to a plus 6 times a minus 6. Everything's factored. Let's cross some crap out here. They both have an a minus 6. Fun! Anything else? Oh, a plus 5. Whoa! That's it. Our denominator is gone. It's a 1. So we have a plus 2 times a plus 6. Leave it as your final answer. If you'd like, you could FOIL that out. It would end up being a squared plus 8a plus 12. But why bother? All right, here we go. We're going to do C because there's a curveball on it. And then I would like you to actually try the other two. Now, C, the reason I wanted to go over it is because this first fraction, we have a number in front of our n squared, which makes it a little more challenging. So always look for a common factor, which there isn't one, because sometimes when you factor out a common factor, then it takes out that number in front, but not here. So remember, we have to multiply first and last. 6 times negative 6 is negative 36, which means they have to be 5 apart. Factors of 36 that are 5 apart would be 9 and 4. So we'd make it n minus 9 times n plus 4. But remember, when you have that number in front, we have to try to divide both of those terms by the number in front. So we're going to try to divide them both by 6, which you can't do that. But both of those fractions can be simplified. So 9 and 6 are both divisible by 3. 3 goes into 9 3 times. 3 goes into 6 2 times. And then we'll take the 2 and we'll move it to the front. So that would become 2n minus 3. Over here, 4 over 6. They're both divisible by 2. 2 goes into 4 2 times. 2 goes into 6 3 times. And then the 3 would move to the front. 3n plus 2. So that's the numerator in factored form. We have to do that same thing with the denominator. 2 times negative 3 is negative 6, which means I need them to be 1 apart from each other. That would be 2 and 3. So that would be n minus 3 times n plus 2, but we have to try to divide them by the number in front, which is 2. I can't do 3 divided by 2, so the 2 moves to the front, becomes 2n minus 3. Ooh, I already see a common factor that's going to cancel out. Over here, we could do 2 divided by 2. It's just 1, n plus 1. So that's the first fraction all factored up, which was a real doozy. I tell you what, we're going to change this to multiplication. We're flipping this fraction upside down. So now the n plus 1 becomes the numerator. The 2n minus 3 becomes the denominator. And now we're ready to cancel, baby. All right, I see a 2n minus 3. Unbelievable. Now, there were two 2n minus 3s. You can only cancel out 1 for 1. So if you had 1 in the numerator and 3 in the denominator, just 1 for 1. Anything else? Yeah, n plus 1. That's it. So we're left with 3n plus 2 in the numerator, 2n minus 3 in the denominator, and we're having fun. All right, so give this a try. Give it a whirl, man. Try it out. A minus 2 over ab times a over a minus 2. The a minus 2's will cancel out, and we can cancel out an a for an a. All we're left with is a b in the denominator. You do have to put a place filler in the numerator, though. All right, factoring these up, 5m plus 10, they have a 5 in common. That leaves us with m plus 2. 2m minus 20 has a 2 in common, leaves us with m minus 10. We're changing it to multiplication, so now the 7m plus 14 is in the denominator. Those have a 7 in common, m plus 2. 14m and 20 have a 2 in common, which leaves you with 7m minus 10. Cool, what can we cancel out? I see an m plus 2, that's cool. I see a 2 on the outside. Anything else? No. So up top we have 5 and 7m minus 10. Denominator we have a 7 and the m minus 10. Now, there's some similarities there, but it has to be the exact same thing for us to cancel it out. So this is all we can do on that one. All right, we have one more type of problem, and it's similar to what we just did. It's dividing again, but, oh, we're dividing by a polynomial. Look, it's over 1, right? This is 5x squared plus 5x over 1. So we're just going to change it and make it 1 over that when we multiply it. All right. X squared plus 3x plus 2. Factors of 2 that add up to 3 would be 1 and 2. X plus 1 times x plus 2. Our denominator is 4x. We're changing this to multiplication. We're flipping this over, the reciprocal, so the 1 becomes the numerator. 5x squared plus 5x becomes the denominator. Do they have anything in common? You bet your face they both have a 5x. 5x times x is 5x squared. 5x times 1 is 5x. Anything cancel out? Oh yeah. X plus 1's. That's it. So our numerator is x plus 2. Denominator. Now, I've been saying we don't need to multiply them. That was like when we had x minus 4 times 5x. You don't need to multiply them like that. But these are just a monomial times a monomial. So we could just multiply them. 4 times 5 is 20. X times x is x squared. That would be our final answer. So I believe I have some problems for you to try. And I feel comfortable with all of them. Now you're dividing by just something over 1. Change it to multiplication and put 1 over whatever you see there. Try them out. Check back in when you're done. All right, so there's everything factored out. Let's see, we have x to the third, x to the fifth, our old property of exponents. You subtract when you divide, and there's more in the denominator. How many more? There's 2 more in the denominator. So they'll completely vanish from the numerator, and then in the denominator there will only be 2 remaining. Anything else? Yeah, 3 goes into 15. 3 goes into 3 once. 3 goes into 15 5 times. So we have 1 over 2 times negative 5x squared is negative 10x squared. And then again, you typically don't write your negative in the denominator, so either write it up top or out in front. On B, nothing cancels out, really? All right. So we have y plus 3 over y plus 2 times y plus 2. You can clean that up at least and make it y plus 2 squared. That's pretty cute. And this is it. Let's cancel some stuff out. Z minus 3, out of here. Z plus 5, gone. All we're left with is 1 over z plus 4. Look at us multiplying and dividing rational expressions.